Hey, I'm out birding today, so some of you might want to know what is birding. Well, it's basically walking around and looking for birds. You know, you have this giant checklist of birds, you try to figure out what they are. So we're at Hudson Mills today. Come on, let's go try to find a bird.
Scarlet tanager way up in the tree up there. I'm gonna try and get a picture of him. Really red. It's really pretty.
Hey, welcome back to our last week, our last set of lessons here. And I had some requests to clarify some of the stuff that we did last time, so I want to just go through that. So we have a couple reactions we did. We did a burning combustion reaction, and in the combustion reaction, so in every reaction we have bonds breaking. We put energy in to break the bonds, but then when they make new things, the energy gets released, and we have energy going in, we have energy coming out, and that's not going to be the same. So in the burning reaction, we can feel heat. It gets hot. You can see the temperature. The temperature is here. Go backwards. See this. So the temperature is 70, and if I put it by the thermometer, by the candle, you can see it really goes hotter. So you can feel heat coming out. And that's because I put some energy in to break the bonds, but then a lot of energy gets released when I make new bonds. I make carbon dioxide, I make water. And because I have more energy being released, the shape of the energy diagram looks something like this. And so you can see here, the energy goes up a little bit, but then it drops a lot, and that energy overall is being released. And so we feel that energy. We are part of what we call the surroundings, and we feel that heat. And the other reaction, this one here, if I have vinegar and baking soda, and I put the vinegar like this in the baking soda, and so this temperature starts off at 60 something, and I put it here. There you go. You can see it now. Put a little bit in this like this. Okay. So the temperature, you can see, is going down here. All right. Where is that energy coming from? Well, now this energy diagram looks a little different. This energy diagram looks kind of like this. We put a lot of energy in to break those bonds, but then not as much energy gets released when you make new bonds. And where does that energy come from? Well, it comes from us. It comes from the outside. It comes from the thermometer. And so everything around the reaction is being pulled into the reaction, and now that energy is going into the process. And so that energy diagram looks a little different. The overall energy is the arrow that's going up like this. And so we have a lot of energy going in and not as much energy coming out. So that's kind of a summary of the last set of lessons. We have several lessons kind of leading up to this. And now what I want to do today is kind of look, instead of at energy, we're going to look at what's happening to the mass of a reaction like this. And so I have here a bottle. This is not a water, it's a water bottle, but it's got vinegar in it. And so if you want to set this up, you just need a little plastic bottle like this, a little bit of vinegar. You need a balloon, and I just have a plain balloon. And what you're going to do, and you need some baking soda, okay? So I'm going to set this up, and I'll be right back. All right, I'm back. We actually had some change in plans in what we need for this experiment. So there's a couple parts to the experiment. The first thing we're going to need is a scale. So I have a kitchen scale here. It says hello when you turn it on. It doesn't actually say hello. I'm going to change the units so we're in grams. Okay, so we're in grams here, and then we need our little water bottle and some vinegar. Okay, so I have some vinegar in here. Put that on the scale, and then if you just use a sheet of paper, so I just took a sheet of note paper, but whatever, and just fold it so that you can pour stuff easily. I'll put that on the scale also. And then we're going to take our baking soda. So our baking soda is our the substance we're going to react. We're going to put that onto the paper. So try not to get this everywhere. We want to make sure we're keeping track of the mass. So everything right now together weighs, if you can see here, 55.5 grams, 0.3 grams, okay? So 55.3 grams. And what we're going to do is, well, first, normally in class, I would have you make a prediction and write down a prediction. So right now, take a second, pause the video, and make a prediction. What do you think will happen to the mass when I pour the baking soda into the vinegar? I'm going to leave the paper on the scale. So I'll pour it in, leave it on the scale so we don't change the amount of anything, but what's going to happen to the mass. So go ahead, pause it, make a brief prediction on your paper. All right. Okay, so now we're back. I'm going to go ahead and do this. Watch the mass and see what happens when I pour the baking soda into the vinegar. Oh, no, the scale turned off. I got to turn it back on. Hang on. Okay, so still 55.4. Okay, so it's close enough. 55.4. Ready? Here we go. Put this in. Oh no! Ah! Bubbled everywhere. Okay, that was a major fail. We're gonna try that one more time. We're gonna use a bigger bottle this time. So if you have a bigger bottle, get a bigger bottle. Turn this on. Scale still works, so that's good. So I'm gonna put this on. Put this on. Baking soda. All right. So starting mass, 104.5. What will happen to the mass? And I mix the two together. Pause. Okay. Probably the same prediction. Here we go. 104.5, 104.4, close enough. And we're going to mix. Put the paper back on the scale just to make sure I don't lose the mass. And what do you see happening to the mass? So, the mass. Final mass, 103.6. Now, here's the question. What happened to the mass? What is this reaction doing? So I will make here's the chemical formula for what's happening with the reaction. You can take a look at the formula and see what's going on. But what is this reaction doing? Where is the mass going? Okay? So does the mass disappear? Does it go somewhere? Where is it going? Why does the mass do what it does? Okay, now here is the real question. Okay, so I'm going to do this experiment again. Once again, I have some vinegar in here. But first, I'm going to use a balloon. So this balloon, if you have a balloon, take a balloon and blow it up first. Stretch it out. Make sure it's nice and loose so that when you can do the experiment, what we're going to do with the balloon is going to act as the delivery system for the powder. So I have this balloon. I'm going to weigh it. Turn on the scale. I'm going to weigh the balloon just by itself. So here we go. Balloon by itself. weighs 2.9 grams. So 2.9 grams. Okay? And I'm going to take the thing here. I'm going to put this on here. And I'm going to take the piece of paper, pour some baking soda on the paper. Okay? And then I'm going to take the baking soda and pour it into the balloon. So let's see if this works. Well, it's kind of a mess, but let's get as much as you can in there, as long as it doesn't get on the scale. Right now, we just want to make sure that we can weigh it all. All right. So I have baking soda and balloon. Make sure there's nothing. It's all in there as good as possible. And then what you're going to do is we're going to weigh this all together. So now what we're going to do is going to take the balloon and you're going to put it on top of the bottle so that no air can get out. But we're not going to dump it in there yet, okay? So it's still 117.3.2. I haven't done anything. So 117.2. Let's call it 117.2. That's our starting mass. Pause it here. Make a prediction. When I dump this into here, what will happen to the mass? When I dump this in and into the vinegar and cause it to react, what will happen to the mass, and why do you think that will happen? So pause it and then come back in a second. Okay, so now we've paused it. Are you ready to do this? I'm going to take this and I'm going to go ahead and mix it. Okay, you can see it's reacting. The gas is going in here. Okay, so we're back. Did you make a prediction? Now, look at the scale. Here's what it is. 117.2. Why does the mass stay the same when we do this? So go ahead and write down your predictions, write down your responses, and then we can talk about this next time. All right, one more thing I forgot. So we have this balloon here. What I'm going to do is I'm going to take this balloon, I'm going to tie it off. I'm going to try to not lose any gas in doing this. So let's go ahead. And remember, the balloon weighed something, right? We weighed the balloon before. Do you guys remember writing that down? How much the balloon weighed? I want you to look at the mass now. 113.2. Can you predict how much this balloon now weighs? Does it weigh the same as it does before? Or does it weigh something more or less? And why? What's causing the change in mass, if there is a change in mass for this balloon here? If we weigh it, okay? So I'm going to weigh it now, and we'll find out next time.